Okay, here we are at Belmont Mall Studios, and we're looking at a problem with the Trident Series 80 console. Cell phone video, so excuse it if it's odd. So channel 25 has an issue, and you can see that the engineer has put a skull and crossbones over it, indicating most likely a problem. And he says just no signal through this. So right now I have come in and connected my signal generator, which looks like that, to line input of channel 25 through this cable. And got the master fader up. Line selected. This is the line gain. It's at 0. It's assigned to the stereo. Plus, fader's up, and we get nothing. One of the most common problems in a console like this are normal throughs. And there's a normal through between the channel out and channel in, the insert, send, and return. So I'm going to patch those. And if the normal through is a problem, that would fix it. It didn't. And I am just looking at meters. I'm not listening to it because I don't really want to listen to tone. But if I could put music through and listen to that, just as easier right now. So that didn't work, and the next idea is to go into a mic input. So patch bay for the mics is over here. I'll patch that into 25. Go to the channel, select mic, crank the gain up, and there I get the tiniest bit. So I've got minus 20 dBu going in. According to the channel, I should have 60 dB of gain, and I'm at pretty close to minus 15. So I'm getting a little bit of signal. And that's what it sounds like. So it's distorted, kind of nasty, but it's there. But again, way too low level. So it's sort of getting through, but not entirely. I did check another channel to make sure everything else was working properly, and it is. So it is simply just this channel that is a problem. So the next thing I'll do is cut the channel in half. So there's the mic preamp and line input section, and then the rest of the channel. And the easy way to separate those is to go into the insert return. So I'll plug a line level feed into that, and nothing. And I'm still set on mic, but that doesn't matter because we're not using that input section. So nothing. So next thing we should do is pull the channel out and see what it looks like. So I'm going to set the camera down for a second because I can't pull these out with one hand. There it comes out like that. The channels connect through these connectors down at the bottom, which are called card edge connectors. There are the connections on the channel strip. There are 2 sets of those for the 2 connectors in the console. And higher end consoles do this. They allow you to pull a single channel strip like this. It allows you to swap out really easily. If you have a spare, you can just toss a spare in that you know works. We do have a spare, but I'm going to try and fix this channel as a starting point. So the first thing to do is to look at the channel and see if we see anything visual. And there we do. Let me get this to focus. There's a capacitor that's charred. It's kind of black. It's also poking out on the end. So that capacitor has gone bad. It's blown up. Possibly from too much voltage, possibly just a bad capacitor that found that moment to die. Now this is on the group mix amp. So that should just affect the submaster out for channel 25. If that's the only problem here, it's doing more than that, which is possible, depending on how it's shorted. So we'll start off replacing that, and then we'll start checking the rest of the channel. Okay, so that capacitor was replaced. It did not fix the problem. I didn't think it would since it was in the submaster output. I didn't see anything else visual on the channel to look at right away. So I put it back in to test it, make sure that capacitor didn't fix it. So now what I want to do is check at the fader. This is another relatively easy place to check. Pulled 2 screws already. Pull the fader out of the console. I'm going to test it with my oscilloscope. I've got this little oscilloscope, little digital oscilloscope I carry in my toolkit. Ground, so that you can tell is the shielded wire, the shield of the wire, because of the way it's got a little insulation sleeve over it. And then of the other two, one should be the send to the fader and one should be the return. I happen to know that the middle one is the send to the fader. You can see there that we've got signal. And the top one then is the return from the fader, out of the fader. And you can see now as I adjust the fader, that goes down. And that's working as it should. That's nice big peak voltage, nice and clean. I've got a whole lot going in right now, more than +4, just to see what would happen. So that's good. I'm not concerned at all. So everything's getting to the fader fine. So it's somewhere after that. So now I'm going to do some more checking on the channel itself. Okay, so I pulled the channel out and then put it back in with these extender cards. So these are just printed circuit boards that move the channel up to where I can work on it while still having it plugged into the console. In this case, I had to make these because this console didn't have any and I couldn't find them sold anywhere. Making the PC board's not difficult. Finding the connectors, the right type and size, was really difficult. I had to order a bunch of different ones that said they were the right size that weren't, and then finally found some in the United Kingdom and paid quite a bit for them. But really invaluable in doing this sort of work. So now I'm going to poke around and test and see what I can find. Okay, so skipped a little bit because it was just too hard to get the camera going. With the channel up on the extenders, I tested and the signal was not getting back from the fader, even though we saw it was coming out of the fader with the wiring. So I pulled out the faders to look a little bit more at the wiring between the fader and the card. And there's some extra electronics in there. And this is what I found. I don't know if you can see the little nut in there. Nice warm place. Wires are made out of, the insulation on wires is particularly enticing to mice. There's something about what it's made from that mice are particularly fond of. And there's huge amounts of damage done. It's amazing that the problem was reported was as minimal as it was. That's partly because this is all for an automation system that's not currently being used. But for channel 25, so this is the wiring for channel 25. You can see this wire. You can see that. That should be connected. It should be connected to this, which obviously should be connected on the other end. And these ribbon cables are for the automation systems, and those have to be repaired. And then also, you can see there's another gray wire there that's disconnected. This looks to be the other side of that orange wire that for channel 25 that's not connected anymore. So yeah, this is going to be fun. And you know, there's some insulation they pulled in to keep warm, a nut to eat. I don't think they ate. So really large amount of damage here. The ribbon cables, those are going to have to be replaced. You can't repair those. because of the time frame I'm under, because they're starting back tomorrow, I will clean this up, get all the junk out, repair that wire, that orange wire temporarily, and that gray wire temporarily, and anything else I find that's in use at the moment that needs fixed, and get all the mouse droppings out and the insulation, which is not particularly fun. One of the caveats to doing that is that aerosolizing those, putting them in the air, is not good for you. So using a vacuum to get them out is not great, but it's going to be hard to get them out with a broom, so I'm not sure what I'm going to do. I'll probably use a vacuum and a mask. So this is the fun part of electronics. Yay! Okay, here we are back. I fixed those wires, temporarily at least, and now fader's up. And we have lovely tone going through. So, simply a little mouse damage. Not fun to clean up, took quite a while. Took about an hour and a half to clean all that up and fix it. So now we can take the sticker off.